stand up here. Okay, notice the levels. The B is a subscript. Don't write your logs too small and forget where the subscript is. Now we still have A, H, and K. All right. I'm going to write my A as a capital so that it doesn't look like a number. And the reason that we evaluated logs first is so that we could try to plug in and plot some points. And we're going to start with our base more than 1, okay? And we're just going to make a table of values. Okay, so we're going to try to graph this one, right? That's what we're going to try to graph. So I'm going to put some numbers here. Let's try 1. Leave a little bit of space before. Let's try B. Can you plug in those numbers and evaluate? Okay. And when I say evaluate, okay, looks like, okay, so log base B of 1 equals y. Can you figure out what y is? We just did a lot of rewriting. Could you rewrite it and figure it out? It's 0. Why is it 0? Anything to a 0 power is 1. And so my first point is 1, 0. Okay? I'm going to try the second one. This is just scratch work. Okay? It's just me trying to figure out what points are going in this table. Log base B of B. What is y? 1. B to the first power is 1. B to the first power is 1. Okay. What kinds of things can I evaluate? We're not going to write all of these, but do you see a trend here? If I'm inputting a value, I have to input powers of b. So we'll do b squared. You get 2. But I'm not going to go further than that. We're going to go backwards. We left a little space at the beginning of our table. Okay. Right? That's scratch work. I don't need to write that down. That's just how I evaluated. Okay, so now I'm going to try this. What could I plug in? Right? You've got to pick a number that you can actually work with. Log base b of what? What can I plug in and actually get an answer? Think of your powers. What does that give you? Gives you -1. If I plug in the reciprocal of the base, I get a -1 power. Is that statement true? Right? Because that's what I'm doing. I'm just plugging in the x's and I'm figuring out what the y is. I plugged in 1 over b and the output was -1. I plugged in the reciprocal and the exponent was -1. Okay? What if I plug in the reciprocal squared? -2. Okay. Let's take those numbers and let's actually put them on the graph. Okay? Well, this is the only one that I can actually plot. Keep in mind that we said the base is bigger than 1. So I'm just going to put it over here. One, 0. B1. 1 over b, -1. Okay. What integer is 1 over b? What two integers is 1 over b between? Well, it's less than 1. More than 0? Yeah? Okay. Let's put it here. What about 1 over b squared? What if b were 2? You would get 1/4 -2. Here. What if you do 1 over b cubed? That's like 1/8 -3. So we're going to get an asymptote is what's going to happen here. Because is there any way to get an x value of 0? No. Can you plug in 0? B to what power? Okay, this one I'm going to write down. Log base b of 0 equals what? B to what power is 0? Nothing. Nothing. You cannot get a power that will turn this into 0. Undefined. Oh, an undefined value means asymptote. That's what it meant in Unit 6. Gave me a vertical asymptote if it was undefined. Same thing in this unit. Just happens to show up in a different way. Vertical asymptote because it was undefined. All right, connect the dots. Similar shape to exponential, just oriented a little differently. One over b -1. Yes.
So the y-coordinate will always be the exponent?
The y-coordinate will always be the exponent, correct. Okay, yes. Yeah. As long as you're plugging in the correct power of the base. So this is not an asymptote. Notice I did not put a horizontal asymptote. It just grows really slowly. And so this next point over here would be b squared 2. And so it depends upon what the base is, how fast that arrow goes up. But it does go up. Okay, so let's label this with our domain and then our range. Our domain is open 0 to positive infinity because all of the x values have to be positive. The range, down arrow, up arrow. I know it looks not very steep, but it does keep going up and up and up. Okay, so we're going to do two simple ones, and then we're going to put in some transformations. Let's do log base 3 of x. We'll just, no transformations, we'll just put an actual base in there. See if you can graph the asymptote and 3 points. Asymptote and 3 points. Anybody else need tape? Okay, so I drew it, so you can check it. I added a 4th point, but I only needed 3. Whoop. I'm going to highlight the 3 points. Those are the points. That's it. Notice the point that's closer to the asymptote. That's the arrow goes down because the point on the left and down is closer. I'm going to write another statement here. As x goes to positive infinity, y goes where? Positive, look, positive infinity for the x's, positive infinity for the y's. I'm in quadrant 1. Where is your arrow? Quadrant 1. But it's pointing up. It's not horizontal. It's pointing up. Means that it's plus, 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 plus. Okay. I'm going to write another statement. This one's a little bit different. 0 on the right. Oh, we had a little bit of that last unit. As I approach 0 from the right side, so I take my right hand and I put it on the graph, on the right side, and then I just trace the graph. Where's the arrow headed? Negative infinity. That's what from the right means. You literally put your finger to the right of 0 and then trace it towards 0. It means trace the graph towards 0 starting on the right side. Oh, the y-coordinate? It's pointing down. Pointing down means negative infinity. Look at my range, negative infinity to positive infinity. Look at my domain, 0 to positive infinity. Sometimes those statements are very connected to your asymptotes. Okay, I'm going to give you one more with no transformations, and then we'll try some with a transformation. Log base 1/4. Okay. 3 points and an asymptote.
arithmetic makes sense that way. However, every mathematical property beyond that is simply coincidence. For example, if you're talking about geometry, like that, like, for example, the way that trigonometry works, coincidence entirely.
Okay, where are the arrows going to go on this graph?
Yes.
Take your points.
Math does not exist. It's a placeholder representation of years.
Think about where your points are. What is going to look like.
Yeah. It's also like the way the computer
Yeah, I would probably just
like
think
how we
the
just
powers of
completely
1/4
invented
is what I would do.
a way of
If you plot English. Right, I would stick with powers of 1/4.
But at the same time, we're also hella amazing. You know it.
Yes, good. Good. All right, I see some good things here. So I'm going to go powers of, I'm kind of going to pick my y coordinate first because I'm going to pick my exponent. 1/4 to the -1 is 4. Don't forget the 0. Oh, notice that it's just like the exponentials, the base, the 1, and the 1 over base. You're still picking the same values, they're just a little bit switched. -1, 0, and 1. You're still picking the exponent, it just happens to be the y value this time. It's because exponentials and logs are inverses of each other. That's why they're in the same unit, which is our next lesson. Okay, so let's graph. My asymptote is still going to be at 0 because I cannot get the outcomes to be negative. All right, so we have 1, 0. But this time we've got 4, -1. I'm just going to put the points on the graph so I can see them. And 1/4, 1. Oh, so my asymptote is at 0. Which point is closer? The one on the top. That means the asymptote's on the top. That's your graph. That's it. Domain, still 0, positive, infinity. Range, it should go in order, negatives to positives. And then I'm going to write my statement. 0, and instead of saying right, I'm going to say plus because it's just much shorter to write a plus. Plus always means the right. We're kind of mixing those end behavior statement, right? This one's end behavior. This one is just vertical asymptote. And I look at my graph to answer these questions. Quadrant 4, that's plus minus. 0 from the right. So I just put my finger on the right side of 0. Arrow goes up. Okay. It's just like your exponential growth and decay. They just swap which side the asymptote is on. All it's changing is whether the asymptote's on the bottom or the top. But the points are all very similar. They're just in the reverse order. Okay? Now we're going to put in some transformations. Here we go. You should have 3 graphs already ready. Okay. And let's transform.
Whoa.
Number 4. Y equals log base 2 x plus 3 minus 4. Okay. Transform. Left 3, down 4, base 2. And I'm going to keep track of the base because that's going to tell me where to put my points. Well, if I was looking at the graph, what shape? I had a shape with an asymptote on the top and a shape with an asymptote on the bottom. So I have to decide, where am I going to put this graph? Where am I going to put my asymptote?
Would it just be left 3 down 4?
It is left 3 down 4, so I'm pretty certain that the center of my graph is left 3, 1, 2, 3, 4. Okay, so I'm pretty certain that's the center. Yeah, it is. Does my asymptote go through the center? Where is my center on the parent? The origin. Yeah, it's always the origin that you're moving. You just have to orient it according to that. So my asymptote is going to go here at vertical asymptote x equals -3. Because I've got my center, my asymptote goes through the center, just like it did for exponentials. Now my points, I got to do my points compared to the center. So I'm going to take away my transformations, right? That's my parent, log base 2 of x. Pick 1 to 3 points to plot, and then draw your shape. 1 to 3 points is fine. The better you get at it, the fewer points you need. Right? Because we've got asymptotes. We've already got guidelines. When you use more characteristics, right, and behavior asymptotes, you need fewer points. Okay, 1 to 3 points in those two statements. Tape is right there. Okay, so my points are going to be 1/2, 1, 2. Right? Powers of 1 or powers of 2. So this one's the reciprocal. This is the 0. This is the 1. Two, 1. All right. So here we go, and graph. That means, right, the arrow doesn't quite look like quadrant 1 yet, but it's going to keep going. It's going right and up. This one is going to -infinity.
How many points are we expecting to grow?
1 to 3. Can't do less than 1. Don't need more than 3. Really, you'll just give me as few points as possible, listing whatever points I ask for. Yes.
So that your points are based off
The base. This is the part that's telling you the points. 2 is the base. Right? So if I was doing exponentials, it would be like 1, 2, 2, 4, 3, 8, 4, 16. I'm still basing these points off of base 2. Okay, here is what I'm evaluating. 2, 1/2, that's a -1 power. 2, 1, that's a 0 power. 2, 2, that's a 1 power. Right? So in my head, I'm spiraling or I'm rewriting it to figure out the result. Okay. Domain, -3 to positive infinity. Range, all real numbers. Okay. Let's make this interesting. There you go. Okay, yeah. That's it. Okay, so I started with some of the basics here. See if you can't actually fill in the shape. Right, I just listed out what my transformations are and the characteristics that came with it. That's not necessarily the hard part. We're used to listing out transformations. AHK, always do the same thing. Now where do you put the graph? 1 to 3 points, okay? 1 to 3 points in the correct shape. Oh, no, JK, you're right. Oh, one mistake. One mistake. Super easy. It's not 0. It's going to be 1. And up here it should have been -3. It should have been the vertical asymptote. That's what I was looking at. Good catch. Good catch. Okay. Oh, times -2. Notice the 0 didn't move. 0 didn't move. Oh, my center is, here's my center. I got to keep track so I count my points from the right place. 3, 1, 2, 3, 2. There you go.
Wait, Mr. Greasy, wouldn't
Yeah.
that be,
But because of the reflection, the arrows actually are correct.
no, I'm not talking about the errors, I'm talking about the numbers. Wouldn't it be just regular 2 for 1/3?
No, because it was times by negative.
Oh, is that
Yeah. Okay, so this is here, and this is here. Okay, there you go. Your homework is